question 6 is all about fish. There's this lake, and they happen to know the average length of all the fish. And therefore, we call that the population mean. And the symbol for population mean is mu. So mu is 8 inches. So they start off the question 6 by telling you, in the lake, the average length of all the fish is 8 inches. So that's the population mean. And the population standard deviation is 2.25 inches. Sigma is the population standard deviation. And it's a measure of variability. And they also tell us that the distribution of the fish's lengths is normally distributed. So it follows a bell curve, the distribution. So let's say x is the length of the fish. Well, we know a bell curve is centered at mu, and mu is 8 inches. So 8 is the center. And the inflection points are at mu minus sigma and mu plus sigma. So sigma is 2.25. So here is 10.25. And over here is 8 minus 2.25, which is 5.75. And so we have 12.5 and 14.75. And over here we have 3.5 and 1.25. So, what does this bell curve mean? Well, the area under the curve is proportional. So, we all know the area between the two inflection points is 68%. So this shaded area is 0.68. That's the meaning of area. It's proportional. Another meaning for area is probability. So if I selected one fish at random out of the lake, the probability that it's between 5.75 inches long and 10.25 inches long is 0.68, or 68%. So that's just a little review of the normal curve. Now question 6 adds the concept of a sample. And we're only going to look at part A. Let's say that I take a sample of 15 fish out of this lake. In fact, I don't do it just once, but I take all possible combinations of 15 fish at a time from this lake. If I do that, I take all possible combinations of 15 fish at a time and then average their lengths together. I get a curve that we call X bar. And I'm going to draw you what X bar looks like. It, again, is the distribution of all the possible combinations of 15 fish at a time, average, each sample of 15 averaged together. So, X bar I'm going to draw in red. And it's going to look like this. look what happened. It stayed centered at mu, but it got much more narrow and taller. In fact, in truth, it should go a lot taller than that, because the area has to stay the same. Okay. So, the red curve, let me again repeat what this red curve is. This red curve is if I took all possible combinations of 15 fish at a time and averaged each group of 15 together. That's X bar. And X bar has this red curve as its distribution. So the answer to question 6, part A, it asks, find the mean and standard deviation for event A. Event A, remember, is this. N equals 15 fish. Okay? Event A is N equals 15 fish, and the X bar is greater than 10. So what they're asking for is the area under the curve of X bar that's greater than 10. Well, we're not going to find that area for the midterm. What we will do, though, is answer part A, which is find the mean and standard deviation. So, part A is find the mean and standard deviation. Well, the mean is mu sub X bar. It stays the same. It's 8 inches. The standard deviation, however, shrinks. It becomes sigma over the square root of n, which is 2.25 over the square root of 15, which is about 0.4 inches. So here's what you need to know for the midterm. The mean stays the same when you go to a sample, but the standard deviation shrinks according to the formula sigma over the square root of n. Just like this picture shows. The blue line is each fish taken individually. The red line is fish grouped in samples of 15 at a time. And we know that the proportion draws closer to the mean when you take a sample, because the extremes get canceled out. A very large fish, when you include a large fish in a sample of 14 other fish, the average together will move it closer to the mean. So let's say there's this one really big fish, okay? A big fish. Let's say the fish is 18 inches long. That's a big fish. Well, most of the time, when you include Charlie the tuna, big 18-inch fish, in a group of 15 fish, most of those fish are normal sized. And when you average it together, the fact that he's 18 inches long, it gets washed out. So that's why the more you include in the sample, the more narrow and tall the curve becomes.